How's it going, guys? In this video we're going to start taking a look at creating our Q class, which will look very similar to our stat class. However, I myself, rather than copy over the stat class and modify it to represent the Q class, I'll kind of rewrite the Q class as if I was writing it from scratch. So here in this video, my target is to write out the constructors kind of as I did last time. And instead of using type name S, we're going to use type name Q for our class Q. We will have the same private data as our stat class, so we'll have a size, and we'll have a pointer to a Q called data that will act as our dynamically allocated array to store the data for our Q. We will have our Q empty constructor, in which we'll initialize size to 0 as well as data to null. We will also have a parameterized constructor where I'll have some value Q and I'll initialize size equal to 1, because the idea here is that we will initialize data with a newly dynamically allocated Q data type, where Q is again, this is a template, so Q can be an integer, it can be a float, it can be something else, but it'll be initialized with our value as well, its value for data. Then we'll have our copy constructor, which will have the same Q as the Q data type as what this Q is going to be. So I'll get a constant reference to a Q. And then if our Q is empty, we will ensure that this Q now is going to be empty. And so if it is not empty, well, we need to consider a few things. First, we're going to take the size, and I'll have my Q size, and this will be equal to Q.size, where here we call a method that we'll further define to get the size of the Q. That will be done later in this video. After that, we're going to take a copy of our data. So we'll have a pointer to our Q data copy, and it'll be the size of our Q that we're trying to copy over, our input Q. So we'll dynamically allocate space that is the size of the input Q. Then we'll declare an iterator, and then here's where we'll copy it over. So I will be equal to 0, I is less than Q size. We will increment I by 1, and we'll copy our data from our input Q into our Q data copy. Once that is done, we're going to determine, okay, if our Q size is equal to 1, then what we'll do is we'll say that data is, well, it's going to be similar. I'm going to copy this, but rather than Q just of some value, we have no value input in this copy constructor, so I need to dereference my pointer to my Q data copy. And I'm just dereferencing this because if our Q data copy just only contains one value at the pointer, dereferencing it like this gives me that value. Otherwise, we're going to be in the case where the Q size is going to be greater than 1. So I need to allocate that space itself. So we'll have our data is equal to, and we'll allocate a new size for it. So we'll have Q size. Data will allocate the same number of data as our input Q will have. And then in this for loop, we will copy everything over. And it'll be the same for loop, just as we copied from our input Q data to our Q copy. And again, just copying the internal data from our Q copy. Right, so I will be assigning the Q data copy to our internal data Q copy. At this point, our size will be equal to Q size, and then we need to delete our value that we used. And actually what I'll do here is that I'll say if Q size is equal to 1, I'm just going to delete Q data copy. We'll finish this if statement first. Otherwise, we're going to do the array version of freeing the code. Then I gotta fix this mistake. I need to finish that else statement there because I'm always going to have this Q data copy. So in this case, we only copy one piece of data. This other case, we copy an array of data. So I need to transfer the queue size, and then if the queue size is just one singular value, I free one singular value. Otherwise, I delete my array. This is kind of like an improvement upon my stack. So that'll actually close out the copy constructor. So the next what is going to happen is that I'm going to have my destructor, so I can delete my queue. And honestly, this will be quite similar to our destructor for our stack. So then I'll have it kind of, well, exactly as my stack. So if size is less than 2 and our data is not equal to our null pointer, we're going to delete data. Otherwise, we're going to delete our data as an array. And that should be it. So next comes our getters. We finished our constructors, we just finished our destructor, and we need to go about our getters. So the first getter that we're going to be implementing is going to be our size getter, which will simply return our size. Next, we're going to have our method to return the front. So I'll have my front, and that'll be a const, and we're going to return the first dereference. We're going to dereference the original address of our data, which simply means this. Because our data here is a pointer to a dynamically allocated array, if I want to access the first element of this array, I need to dereference the array at the address that it's originally pointing to, because when you have a pointer to an array, it points to its first value. And in the case of implementing the back, it's going to be, well, just like I would implement the top. So I'm going to return our data plus size minus 1, where this will return the end of our dynamically allocated array. And I'm actually going to close off my class here. So this is going to be part 1 of implementing our queue class. So it's quite very similar to our stack class. I would say, aside from our front method and renaming our back method from top to back, all that we've done here is going to be the same, exactly the same as our stack class. And you will see that in the next video when I cover my methods for adding data and removing data named enqueue and dequeue. This will be the biggest difference, and I actually think the rest of the methods will be exactly the same for this class right after, but I'll still write it and give comments about writing them. But with that, I'll see you for part 2. Have fun, stay safe.